Now I am going to teach you working principle of single phase induction motor. Okay, the working principle exactly same as three phase induction motor, but there are some issues in it. Now let us look at first the three phase induction motor. How this three phase induction motor was starting? Let us have a glance. So here we had a stator and rotor. We applied a three phase voltage, and this three phase voltage produced the three phase flux, and this three phase flux was rotating in nature, and that is, it was rotating at the speed of synchronous speed. It was rotating at the speed of synchronous speed. When this flux rotates, it cuts the rotor and EMF is induced. And when this EMF is induced, this EMF now produces the current in the rotor. When the current flows in the rotor becomes the current carrying conductor. So what is the motor principle? Whenever the current carrying conductor is placed in a magnetic field, it experiences a mechanical force. So already the magnetic field is rotating. So this is magnetic field is already available. And now you have a rotor, and in rotor the current is flowing due to induction principle. Now the rotor becomes a current carrying conductor and it is placed in the magnetic field. So obviously the rotor will experience a mechanical force and it will start rotating. So this was the case in case of three phase induction motor. Now what happens in single phase induction motor? Now in single phase induction motor we do not have a three phase system. We have only a single phase. Okay, so we have a stator and we have a rotor, and we give us only phase and neutral. Okay, so we give one a single phase, and the flux produced is also a single phase. So the flux produced is like this. Okay, now what do you mean by revolving magnetic field? So if you have any doubt what about the revolving magnetic field, please refer my previous videos. We have explained clearly what about the revolving magnetic field. So revolving magnetic field means with respect to time, every time there should be some amount of flux, and it should be, that is, the occurrence of flux should be in rotating nature. So every instant, at one instant this is a flux, another instant, another instant, like this. So it keeps rotating like this. Okay, so the flux value is constant magnitude and keeps rotating. This is called revolving magnetic field. But when we look at single phase induction motor, that is in single phase flux, what happens is, now it is clearly visible only one phase. So at this point the flux value is 0, and then we have another amount, other fluxes, and here also it is 0. So when we try to find out what happens inside the machine, that is, when we give the single phase like this flux, what happens is, we can explain this using a double field revolving theory actually. And what the conclusion is says that this single phase get divided into two portions, that is, one divided by phi m by 2, I mean one is phi m by 2, another one is phi m by 2. What is phi m? So the maximum flux we consider it as phi m, because these values are unknown, so only this is the reference. So the complete flux which are produced here divided into two halves, and one rotate in the clockwise and another one rotates in the anti-clockwise, so that one produce the forward torque and another one produce the backward torque, and both are in equivalent magnitude and get cancels each other. So hence we say that the net torque, the gross torque, is 0. So the single phase induction motor does not rotate on its own. It's not a self-starting machine. So a three phase induction motor was a self-starting machine, but single phase induction motor does not a self-start. It is not a self-starting machine. It needs some arrangements. So we that is why in case of three phase induction motor we don't have starting methods like we use internally. We don't have different types of machines, we don't have. But in single phase induction motor we have different types of machines. Like we have a split phase induction motor, we have repulsion motor, we have shaded pole induction motor, like this, because we do some changes in the construction in order to make it self-starting. Okay. Now, so the conclusion is single phase induction motor is not a self-starting machine. Now, what is next? We actually, the thing is that when we are seeing at our home, all the home appliances, most of the home appliances are made up of single phase induction motor only. So the immediately one point comes in our mind, three phase induction motor self-starting and single phase induction motor is not a self-starting. But why do we use in all home appliances, why do we use a single phase induction motor then? Now the reasons are, first point, in our home, in our homes we have a AC supply, we do not have a DC supply, one point. So we are supposed to use the AC appliances. AC means AC, alternating current, the appliances which uses the alternating current. Okay, fine, we have to use the AC. In AC there are two options, we can use single phase and we can use a three phase. Now why do we, all the home appliances are working under single phase? The reason, first of all, we have to decide what type of applications. Like in home you may use a refrigerator, we use washing machine, we use mixer grinder, we use hair dryer. Now for all these applications, first we have to find out what is the ratings we want, what is like 300 watts, 400 watts, 500 watts, like this, how much works output load we want. So we identified. After finding all the requirements of home appliances, whatever the things we use, we conclude that single phase is itself is sufficient to provide all our needs. So there is no need of going for a three phase, because if we go for a three phase, then what will happen? We will be wasting lot of energy. Like one point we all should remember, suppose if I use a transformer, if this transformer is having high capacity, that is maximum capacity, full load capacity is x kVA something, but if I operate this transformer at this full load, all the machines work efficiently only at full loaded condition. Like suppose if the transformer works under 100 ampere, this is a full load, 100 ampere, 100 amperes is the maximum current, means this transformer will provide high efficiency only in 100 amperes. When we are, instead of 100 ampere, if we are drawing only 50 ampere, then the efficiency will go low. Okay, so it means fullest capacity, every machine should work on the fullest capacity, then only the efficiency is good. Now when coming to home appliances, when we are saying that, when we concluded that single phase itself is sufficient, suppose if it is a washing machine, the single phase supply itself can do this work. Okay, but since the single phase induction machine is not a self-starting, let's say we choose three phase and now we use as a washing machine, what will happen? You actually require only 200 watts, suppose 200 watts, but this will produce a high power, this is the capacity is high, and now what will happen? Since the capacity is very high but you are operating only 200 watts, you are not utilizing at a full load condition, so the efficiency go low. When the efficiency is less, you will be wasting a lot of power in. So we have to use single phase induction motor. Okay, now if we decide that single phase induction motor we have to use, because we can't use DC machine, because we in all our home we have only AC supply, so we can't use the DC appliances. So if you use DC appliances, then again you have to convert AC into DC, then when you convert, then there will be a loss of efficiency. So finally the conclusion is, we do some changes for some modification in the construction of single phase induction motor, so that it gets start in itself, because it is not self-starting. We start by using different methods. So there are multiple methods are available, like split phase method. Okay, so like split phase method and different methods we use. Okay, so this is the introduction of single phase induction motor. This is the problems associated with this. So I hope you have understood clearly. Okay, so once, if you like, please share and subscribe. Thank you.